Alright, so we've looked at a whole bunch of exponent laws now, and what I want to look at today with you guys is how to go through some more complicated expressions that we're going to have to simplify using our exponent laws. So, just a reminder, whenever you possibly can, simplify before you try to evaluate things. If you try to sub in numbers too early to an equation before you simplify, it can make the algebra a lot trickier, and it tends to lead to a lot of mistakes. So I'd like you guys to simplify first before you evaluate. So for here, the first one we have here, it asks you to simplify using exponent laws and evaluate for whatever given values I give you. So I'm giving you 16x to the power 4, all to the exponent 3 over 2, and I want it at the value x equals negative 3. Now, there's not really much stopping you from putting in negative 3 in for x now, and you probably would still be able to get to the answer, but I'd like you to simplify first just to use those rules. And you'll see some examples later where we're definitely not going to want to sub in the value first. So what I'm going to do here first is take my exponent and make sure it goes with everything inside the bracket there. So using that law that we reviewed in the last couple of days, we have, let's say we have a times b all to the exponent n. That's the same thing as having the exponent go to both the a and the b. That's what I'm going to be doing here. So this 3 over 2 exponent is going to go to the 16 and to the x to the exponent 4. So it's going to simplify as 16, the exponent 3 halves, and x to the exponent 4 all to the 3 halves. Okay, and I can simplify here with my x's exponent, power of a power, so I can multiply the exponents. So I get 16 to the 3 halves times 4 times 3 halves is 6. Okay, so I'm going to simplify this one now. I'm going to work with the 16. So using my rational exponent rules, because it's a denominator of 2 in the exponent, this becomes the square root of 16 all to the exponent 3 times x to the 6th. So this becomes square root of 16 is 4, 4 to the exponent 3 is 64. So I get 64 x to the 6th. Now that I simplify as much as I possibly can, now I can use the fact that x equals negative 3 and substitute that in the equation. So it's going to give me 64 times negative 3 to the exponent 6. Okay, and just to finish that off, negative 3 to the exponent 6 is 729. When you multiply that by 64, you get a large number, 46,656. Okay, so that's a typical type of example you might see. So you're going to want to simplify it first as much as you can using exponent laws, and then sub in the given value. And the reason I want you to simplify it first, if you look at something like b, for example, b looks like an absolute nightmare. And if you just sub in the 4096 right away, well, you can see right away, the first thing it's going to have you do is take 4096, you have to put that to the exponent 7, which is a huge number, multiply that by 256, even bigger number, and you get something that's really, really tough to work with. So you want to simplify this as much as you can first. So that's what we're going to do here with b. Okay, so what I'm going to do first is just try to rewrite things. Instead of in radical form, I'm going to put them in exponent form. So I'm going to leave the exponent 2 alone for now. I'm just going to simplify what's inside here. So what I have right inside, I have 256 x to the 7th, 4th root of all of that. So I'm going to rewrite that as, in brackets, 256 x to the exponent 7. And the 4th root means that's all to the exponent of 1/4. Okay, for the next one, it's a square root of 25x to the 2/3, so that's going to become 25x to the 2/3. And the square root means it has an exponent of a half. Okay, and down here I have cube root of 27x to the 5th, which will give me 27x to the 5th power, all to the exponent of 1/3. And of course, this entire thing is squared. Okay, so it seems very, very messy, but now what I can do is actually start doing what I did before. I mean, really, I have a bunch of expressions like the one I did in A. I just got to simplify them each individually. Okay, so let's take this a bit further here. Let's see what we can do. Okay, again, I could deal with this squared right now and just multiply it through all the exponents, but I'm going to simplify inside first as much as I possibly can. So this is going to give me 256 to the 1/4, and x, power of a power, 7 times a quarter is 7/4. Okay, so the next one I have 25 to the 1/2. Okay, and for my x, it's 2/3 times 1/2, which is 1/3. Kind of switch colors there, but that's okay. And for the one, my green one here in the bottom, it's going to be 27 to the 1/3. And then it's going to be x, 5 times a third is 5/3. Okay, so now what I'm going to do, just take it a little bit further here. I'm going to deal with all these numbers here. So I have 256 to the 1/4. So I'm going to rewrite that. Sorry, first let me just get my big brackets here. 256 to the 1/4 is just the 4th root of 256. Okay, and again, just going to deal with the numbers right now. So I'm going to deal with the 25 to the 1/2. There's all multiplication here, so the order in which I do it doesn't actually matter. So I'm going to put this one next. So 25 to the 1/2 is the square root of 25. Okay, and that's going to leave me still with x to the 7/4 and x to the 1/3. Okay, and my denominator, 27 to the 1/3 is really just cube root of 27. And then I have my x to the 5/3. Okay, so the reason I just wrote the x's a bit separate like this, so I could see how I could simplify, right? So here I have 2 powers of x. So since I'm multiplying these 2 powers of the same base, I can add the exponents together. And then I could subtract here the x to the 5/3 from the exponent because this is being division. This is being done with the division. So off to the side here, just to remind myself here that for my x variables, this is going to be the same thing as x to the exponent of 7/4 plus 1/3 minus 5/3. Okay, so again, just to recap here, I'm multiplying these two x powers together. Okay, so I'm adding the exponents, and then here I can subtract the exponent of 5/3 because I'm now dividing by that. So I'll trust you guys to do the fractions on your own here, but when you put those together, 7/4 plus 1/3 minus 5/3, it gives you 5/12. Okay, so all those x's simplify quite nicely. Just take it a little bit further here. Oh, I dropped my exponent of 2 there. Can't forget that. Okay, so inside here, 4th root of 256 is 4. Square root of 25 is 5. Okay, and all my x's are simplified to x to the 5/12. And cube root of 27 is 3. Okay, so putting all this together now, I have 20/3 and x to the 5/12. Okay, and if you remember originally, this entire thing was already squared. Okay, so it already looks a lot nicer than it did before. And in theory, it actually probably wouldn't be too bad to sub in the x equals 4096 now. But let's just simplify it a little bit further. Let's deal with that exponent too. So if this is the case here, this is going to be, if I'm distributing the exponent here, this is going to be 20 squared, x to the 5/12 squared, over 3 squared. Now you may not need to write out this step if you just know to distribute the exponent properly, but if it helps, please do write it out. So 20 squared gives me 400. X to the 5/12, so 5/12 times 2 is 5/6. And 3 squared is 9. Okay, so really I've simplified this as much as I possibly can now. Now I can sub in my x equals 4096. Okay, and I'll just work on this 4096 off to the side. So 4096 to the 5 over 6 will be the same thing as the 6th root of 4096, all to the exponent 5. Okay, the 6th root of 4096, you can work that through in your calculator, is 4. So you wind up with 4 to the exponent 5, which is 1024. Okay, so the entire next line simplifies into 400 times 1024 divided by 9. Okay, so you just simplify that as much as you possibly can. So 400 times 1024 gives you 409,600. And that's all over 9, and this does not reduce any further, so you're done there. Okay, so that one took a little while, but again, it's the same ideas we've done before. We're just applying a lot of these rules together at once. Okay, so I'd like you to try C on your own first, and then push play when you're ready to go through it together. Alright, so a lot went on in this one. So you can take a second here and just check your final answer. You should get 256 over 243. But there's a lot of steps that go into that happening. So if you didn't get it right, there might be a little mistake somewhere along the line. Let's take a look. So the first thing I did was distribute the exponent through. So I have 9 to the negative 5 halves, x to the negative 4 to the negative 5 halves, y 6 to the negative 5 halves. I did the same thing with the denominator too. So I distributed 2/3 to the 64, to the x to the negative 3, and to the y to the 21. Okay. And after that, I just simplified it a little bit. So whenever I could do power of a power, I could. So for the numerator here, I have negative 4 times negative 5 halves gives me positive 10. For the y in the numerator, I have 6 times negative 5 halves to give me negative 15. In the denominator, I rewrote 64 to the 2/3 as the cube root of 64 all squared, so I could simplify it later. And then for my x's, negative 3 times 2/3 is negative 2. And for the y's, 21 times 2/3 is 14. Okay, so once I had that done, then I looked at trying to simplify the x's. So I looked here, I had x to the exponent 10 divided by x to the exponent negative 2. I'm dividing powers with the same base. I subtract the exponents. So over here, I have x to the exponent 10 minus negative 2, which is x to the 12. So that gave me the x to the 12 here in this next line. Okay, so for the y's, it's something similar. I have y to the exponent negative 15 divided by y to the exponent 14 to subtract the exponents. Negative 15 minus 14 gives me y to the negative 29. So it gave me that one there. Okay, I've left 9 to the negative 5 over 2 for now. I could have moved it down to the denominator to make the exponent positive. I'll do that in a later step, but there's no reason. I mean, I'm just holding it off for now, but there's no reason why you couldn't do it now. And cube root of 64 is 4, so I just simplified that there as well. Okay. Then what I wound up doing is then I looked to try and make positive exponents. So I took my y to the exponent negative 29 and moved that down the denominator so the exponent would be positive. Okay, and I started to now deal with that 9 to the exponent negative 5 over 2 and move that down the denominator where again the exponent would be positive. Okay, and then at that point it's just a matter of simplifying as much as I possibly could. So 9 to the 5 halves. I did over here on the side is the same thing as square root of 9, all to the exponent 5. Square root of 9 is 3, 3 to the 5 is 243. So once I simplify that down there, I multiply 60 and 243. This is about as simplified as I can possibly get. So then now I can actually put in x equals negative 2 and y equals 1. So I get negative 2 to the 12 over 3,888 times 1 to the exponent 29. 1 to the exponent 29 is just 1, so that part goes away nicely. Negative 2 to the exponent 12 is 4,096. So I get 4,096 over 3,888, which simplifies into 256 over 243. Okay, so there's a lot going on in that one. There really is just one more example I want to do with you guys. I'd like you again to try it on your own first, but I'll take it up in part 2 of the video.